What if you could create a contract that just couldn't be broken? Like a promise that's automatically enforced by a global network of computers. No lawyers, no middlemen needed. That is the real power of a smart contract. But how do you get from just an idea to an unchangeable reality on the Ethereum blockchain? Well, today, we're going to dive into the professional engineering framework that makes it all happen. Okay, so here's our game plan for today. First up, we're going to tackle the big idea, what code is law really means in the real world. Then, we'll get into why Ethereum is still the undisputed champ for developers. After that, we'll roll up our sleeves and look at the actual toolkit, walking through the entire deployment process step by step. And we'll wrap up by talking about the two things that keep every single developer up at night: cost and security. Let's do it. All right, let's jump right in. So, why is this one single act, deployment, so unbelievably critical? I mean, what's the big deal? Well, this is the exact moment a piece of software morphs into something way more permanent and powerful. Okay, think of it like this. A smart contract sitting on a developer's computer, it's basically an architect's blueprint. Yeah, it's a super detailed plan, but it can't actually do anything on its own. Deployment, that's the moment you hand that blueprint over to the construction crew and they start pouring the concrete. Suddenly, it becomes a real, tangible thing that exists in the world. And you better believe it's not so easy to change after that. And really, this is the core of it. We're not talking about a legal document filled with confusing jargon. Nope. It's a computer program, and it runs exactly as it's written. Once it's on the blockchain, it follows its instructions perfectly, forever, and it doesn't need to ask anyone for permission, ever. So you might be asking, why go through all this trouble? Well, because this is where the magic really happens. With this, you can create a decentralized marketplace where the rules are enforced automatically. No humans in the loop. You can lock up billions, literally billions of dollars in assets, knowing for sure they can only be moved according to the rules you wrote. You can tap into the massive global liquidity of DeFi or, create the next big NFT collection that gives your community real, actual ownership. It's all about building trust, but not with a handshake. You're building it with code that anyone on the planet can look at and verify for themselves. Now, I know what you might be thinking. Hey, aren't there a ton of other blockchains out there? And yeah, you're absolutely right, there are. But when it comes to smart contracts, there's still one king of the hill. So let's dig into why Ethereum is still the top choice for any serious developer. So what really sets Ethereum apart isn't just one thing, it's how all these pieces fit together. I mean, it's not just about having mature tools. It's about how those tools make your development faster and, crucially, more secure. It's not just about being around since 2015. It's about the years of battle-tested security that come with that history. And yeah, gas fees used to be a huge headache, we all remember that. But now, with layer 2s like Arbitrum and Optimism, it's become incredibly cheap to actually use the network. But the real secret sauce? It's the network effect. Plain and simple. The best devs, the biggest projects, the most money, it's all on Ethereum. And that creates this powerful gravity that's just really, really hard to escape. All right, so you've decided on Ethereum. Great. But now you've got another big decision to make: choosing your tools. And listen, this isn't just a matter of personal preference. This is a major engineering decision that's going to shape your entire project. So let's break down what's in the developer's toolkit. So, your first big choice, which language? It really depends on what you're building. Are you trying to create some sprawling, complex DeFi protocol with a million moving parts? Then yeah, Solidity, with all its features and its huge community, is probably your best bet. But what if you're building something simpler but with incredibly high stakes, like a vault that's going to hold millions of dollars? In that case, you might want to look at Viper. It's intentionally minimalist and security first. Think of it like a finely crafted Swiss watch. It does one thing, and it does it perfectly. Okay, next up is your framework. This really comes down to how you, the developer, like to work. Are you a JavaScript or TypeScript pro who just loves the flexibility of a huge plugin ecosystem? Then Hardhat is going to be your happy place, for sure. But what if you're more of a security purist, someone who wants to live and breathe Solidity all day long? Then you have to check out Foundry. It is blazing fast because it's built in Rust, and its killer feature, you write your tests in Solidity. That means no more context switching between languages, which, trust me, is a huge win for catching those really subtle bugs. So, with our tools chosen, we are ready to look at the pipeline itself. You can think of this as the assembly line, the process that takes your contract from just a text file on your computer to an unstoppable force on the global Ethereum network. Okay, this is where the rubber meets the road. It all starts with writing and compiling your code. You're basically turning it into a language the Ethereum network can actually understand. Next, you put it through the ringer, a whole barrage of tests on your local machine. If it survives that, you do a full dress rehearsal on a public testnet, something like Sepolia. This is your last chance to catch any bugs in a live environment without any real risk. And only then, only when you are absolutely positive it is perfect, do you pull the trigger and deploy it to the mainnet with real ETH on the line. And don't forget the final crucial step, verifying your code on a block explorer like Etherscan. This is how you prove to the entire world that your code does exactly what you say it does. And just like that, it's live. Your contract is officially on the blockchain. But the journey is not over, not by a long shot. Now we have to talk about the two biggest realities of life on chain: how much it costs and how on earth you keep it safe. The best way to think about cost is like building a house. The development cost, that's what you pay the architects and the construction crew to design and build the thing. The more complex the house, well, the more it's going to cost. Simple. Then you have the deployment cost. That's the gas fees. This is like the permit you have to buy from the city to even start building. And the price of that permit, it can change, sometimes wildly, depending on how many other people are trying to build houses at that exact same time.
And this brings us to what might be the single most important question in this entire space. You can build the most elegant, the most efficient contract in the world. But if there is just one tiny security flaw, all of it can be gone in a flash.
So let's talk about the biggest boogeyman in smart contract security: reentrance. Imagine a really buggy ATM. You go to withdraw $100. The machine gives you the cash first, and then it gets around to updating your balance. A clever attacker could just keep asking for another $100 over and over again before the machine updates the balance from the first request, and just drain the entire account. That is a reentrancy attack. The fix, luckily, is a super elegant pattern: checks, effects, interactions, or CEI. It's simple. You always check all the conditions first. Then you make the effect, the state change, on your own books. And only as the very, very last step do you interact with the outside world by sending the funds. It's a simple order of operations that has saved literally billions of dollars. And all of this brings us to the big final question. With Layer 2s making it cheaper and faster than ever to deploy smart contracts, are we on the verge of a totally new era? I mean, are we looking at a future where our most important agreements are no longer enforced by lawyers and courts, but instead by transparent, unstoppable code on a blockchain? That's the multi-trillion-dollar question that, honestly, everyone in this space is trying to answer.